Just grabbing a little work in progress footage here. You can see it's July 15th. Here's some of the circuitry. Here's a board layout. Let's take a look at 3D. So there you go.
So you may remember quite a while back, I made a little door alarm circuit that was supposed to detect when a door had been open too long and sound an alarm. This circuit right here. And you may remember after designing this, I actually made a breadboard out of it and tested it out to make sure it actually worked on a breadboard. And I'll cut you guys back in after I've zoomed in on the breadboard. And at the end of this video, I said, I am probably going to make an actual circuit board for this, but it may be a little while. Well, here we are more than a year later, and I was applying for a job, and I needed to show them that I could actually do circuit board layout. So I decided I would make this circuit on a circuit board. Now, I wanted to make this in Pads Pro, but unfortunately, trying to make their installer work correctly and trying to work with their tech support when their installer would never ever work correctly were both massive wastes of time. So instead, I downloaded KiCad, taught myself KiCad in about half a day, and then did the layout in KiCad. So let's go and take a look. So here's the schematic. You can see it's identical to the schematic that I put into FalstadSim. All the same circuitry is here. I also went out of my way to make a custom component, the 74HC7001, which was not among either the components or, well, technically it was among the footprints that KiCad had because it's an SOIC 14, 8.7 millimeters long. Anyway, there's the schematic, no big deal. I did put in some fancy connectors that we'll see in a little while, just because I really like these kind of Phoenix connector terminal things. And there's also some other little stuff like test points so that you can solder in the light and the beeper onto the board. So there's the schematic. And let's go ahead and take a look at the actual circuit board layout. So here's the circuit board layout. You can see it's got two power planes. There's a 12-volt power plane here that comes in through a standard barrel jack. And then this plane down here is a 5-volt. I did notice something a little bit annoying about KiCad and the way that it redraws a power plane. Once you've poured a power plane, you see all these sort of blank areas inside here. They're not filled in, and I would rather like them to be filled in with power plane, even though they are islands and they can't touch the other parts of the power plane, at least not without me dropping a via. You can see this little island right in here, I did have to drop a big fat power via on the far side of the board. That's because this little piece of copper in here is an island, and it's also the power for the chip. So all the 5-volt power that goes into the chip has to flow through there. Consequently, you need a great big via to carry, whatever the burst power load is for this AND gate. Other than that, you can see that there really aren't many vias on the back of this. I did do some sneaky stuff that would probably be frowned upon by other people, like running this trace underneath. There's a resistor right here, R4 100K. So I ran this trace underneath, like a tunnel underneath a bridge through there. And there's some other, other stuff that had to go on too. But at the end of it, I couldn't get all of the traces on the top side of the board. So I did need to put one signal trace, this guy, underneath, just because all these pins here are so closed in and enclosed by the traces that are around them. And let's go ahead and take a look at the 3D view. There you go. You can see there's a solder point here for the barrel jack. There's a Phoenix connector right here, a screw-in terminal block. This is for the cable that actually goes all the way out to the magnetic reed switch. And then I put a huge solder pad here so that you could solder pretty much any inductor you wanted into here. The one that I found looked like a little peanut resistor. Down the line, you might have to do, a much larger inductor, and you might need a much larger footprint to solder it onto. So I put a very large footprint here, figuring you could solder almost any inductor that you needed to onto those footprints. Likewise, J3 and J4 over here, these solder pads, these are actually so that you can solder on the wires that power or I should say that ground, since they don't power. You send 12-volt power to the beeper and the LED in the little tower thing, and check out the first video if you're curious to know more about that. I'll leave the link in the description. So these are solder pads so that you can, solder on the wires for the beeper and the LED. Maybe you want to actually see this without the chips on it. There you go. That's what it looks like without the chips. There's your back layer, just that big via to power the chip, and then the little via for the signal right there. Yeah, it's my first time using KiCad, my first real, my second circuit board layout in my life. My first one using KiCad. I hope this gets me to the job interview. If learning KiCad in half a day and doing the circuit board layout in half a day isn't good enough for the people that they won't even interview me, then I think that says a lot about them. So there it is. I hope you've enjoyed that. If you want copies of these files, I've released this under a Creative Commons share-alike license so that anybody can take this, modify it however they want. They just have to give me credit, and they have to make sure that their modifications to it are also published so that, they can't just turn this into a commercial product, not give me credit, and not let the rest of the world know. Here's my GitHub. I'll drop this URL in the description. Go to my GitHub and look for the DoorAlarm repository right here. These are all the KiCad files. Here's a little screenshot of both the circuit board layout and the 3D model. I hope you enjoy.